All right, let's solve this probability question, which reads a password on Mr. Wallace's briefcase consists of 5 digits. What is the probability or chance that the password contains exactly 3-digit 6? Okay, so 5-digit password. So let's say there are 5 slots to accommodate these 5 digits. Okay, now first of all, see, we're looking at probability. So we need favorable cases in the numerator, and in the denominator, we need total number of cases. So first, let's start with total number of cases, right? That's the easier part. Okay. In order to look at those cases, what are we operating with in terms of universal set, right? So what digits can go in these slots? So in the 10th base system that we operate in, 0 to 9 are the digits, right, that we are working with. So there are 10 in number, right? 0, 1, 2, 3, 4, so on and so forth till 9. There are 10 digits which can fit in these slots. Okay. Now, if you look at each slot, for example, if you look at this first slot, if you're looking at total number of possibilities, any digit from 0 to 9 can go and sit there here, right? Unlike, the cases where we form numbers or, 5-digit numbers where the first digit cannot be 0, that will not be the case here because we're talking about passwords here. In passwords, even the first digit from left can also be 0. Okay. So this slot has got 10 possibilities for digits, and so is the case with other four slots as well. So basically, total number of possibilities for a password is nothing but 10 at first place and 10 for the remaining places as well. So 10 into 10 into 10 into 10, 5 times. So that becomes 10 to the power 4. So this is our total possibility, total possibilities. Okay. Okay. Now let's talk about the part where we are looking at favorable cases, right? So what are our favorable cases? Now remember, the restriction is that 3 of these slots have to have one specific digit, which is 6. Okay. Now, in order to move forward, first we need to identify which those 3 slots are out of these 5 slots. Now that can be done in 5C3. We are choosing 3 slots out of 5 where we can place those 6s. Okay. Now, once we have identified those slots, let's say those slots are the slot number 2, fourth, and fifth. Let's say we find out that these 3 are the slots that we have chosen, right? Now, when you place 6, there is only one way of placing that, right? We know 6 is the only digit that's going to sit in each of those 3 slots. So there's only one way of placing those uh, that 6 there. Now we are left with remaining 2 slots, which is our first slot and the third slot. Now in these 2 places, what are the possibilities that we have? The only numbers that can go here from 0 to 9 are the ones except 6, because we need to exactly have 6 at 3 places. If we have at other places also, then it will be more than 3 places. So we cannot have 6 in these 2 slots, first and third slot. So the only choices that we have are not 10 digits. We have only 9 digits to operate with. So each of these 2 places will need 9 possibilities. So 9 into 9 for the 2 slots is 9 squared. Okay. Now when you work this out, this is nothing but 5C3 is 10. 10 into 1 into 9 to the power 2 is 81. So 10 multiplied 81 is 810. Okay. Now, in order to calculate the probability, okay, let me use the color here. So in order to calculate the probability such that exactly 3 6 digits are used in a 5-digit password, so total favorable cases are 810 and total number of cases are 10 to the power 5. If you look at the answer choice, the one that matches is choice B, and therefore this is our right answer. Okay, so another way to look at the same question is, if you look, if you think about what the success looks like when you're thinking at fitting six out, the digit six out of 10 digits, there is one digit which is six, right? So what does a success look? If I were to talk about, what is the probability of finding a six out of 10 digits? That would be 1 by 10, right? So because this is one digit out of 10 digits, right? Okay. What is the probability of not having a six? That is 1 minus 1 by 10, right? Which is 9 by 10. And that is a case where there is, so if we say that P of 6 is what success looks like, the chance of this success of fitting a 6, and P of not 6 is the non-success part, right? So, and imagine that you are thinking about, instead of five slots, we are thinking about five random trials that we are doing. And success looks like 1 by 10 probability, and failure looks like 9 by 10 probability. And if we can find out the three success cases out of those five cases, then we can find out the results. So in order to find three successful trials out of five total random trials, that can be done in five C3 ways. Okay. And since the success has a chance of 1 by 10, so I need to have 1 by 10 to the power of 3, because 1 by 10 happens three times. We have chosen those three success cases by using 5C3. And the non-successful case, which is 9 by 10, happens for those remaining two failed cases. So 9 by 10 to the power of 2. If you calculate this is nothing but 5C3 is 10, 1 by 10 is 1 by 1000, and 9 by 10, 1 by 10 cube, and 9 by 10 square is 81 by 100. This evaluates to 810 in the numerator and 100,000. So I've got five zeros here. Now you can see that this matches our correct answer, choice B. All right, thank you.